Good evening all. Please let me know if you are able to hear me. Good evening guys. I request you all to just drop in a text if you are able to hear me. If the audio is fine, please drop in a text. Thank you, and I presume that the video is also fine for you all. We'll begin the class in a couple of minutes. We'll just hold on. Right, so please hold on to the classes. So we'll begin in a couple of minutes. We are today dealing with a topic called as numbers. So we have Bibin from the tech team assisting us. If you have any trouble, you can always text there. Don't worry, if some things go wrong, they'll always come back. So just have some patience. If you find some technical errors happening, don't worry much. So numbers part 1 is what we are going to handle today for 1 hour of a session. The coverage that I'm going to do here is broken into 2 parts. One is classification of numbers, and the other one where we are going to go deep into finding the unit digit, or what we also call as a cyclicity method. One request or one information that I would like to share to all of you, and the information before the beginning of the class is this. One, we are basically concentrating majorly on the concepts. I would want to build the concepts very strong, only then so that the shortcut methods, if you want to use further, can be useful. So we are going to work big time on the concepts. There are a couple of you who are saying that there has been audio issues. Right, Chaitanya. So Chaitanya, I hope you are able to hear me now. The voice is pretty audible right now. So what we are going to deal with, as we said, classification and trying to find the unit digit of a number, right? So we'll begin the class in exactly 4 minutes. I'm just waiting for people to join in, so don't bother much, don't worry much. So we'll begin. Right, so let's begin with the topic numbers, and let's begin with classification of numbers. So how do I classify numbers into? So I can classify numbers into two portions. One is, most of you know this, that's we are talking about real numbers and we are talking about complex numbers, right? Real numbers are numbers which can be drawn in a number line. Typically, when I look at the examination point of view, complex numbers are not asked, and it's typically the out of syllabus kind of a coverage. So we will not be entering complex numbers, which is the form of a plus ib. We'll not be entering into complex numbers, we'll be entering into the real numbers portion. The real numbers are, if I have to classify real numbers into the further crowd, I can classify real numbers into further two portions, and that is a rational number and an irrational number. Now, when I look at rational numbers, right, so let's understand what rational numbers are. So when you look at rational number, we realize that on a layman method, rational numbers are numbers which can be represented in the form of p by q, where q is not equal to 0. So typically, if I say 1 by 2, if I say 1 by 3, if I say 4 by 1, they're all rational numbers, right? And which implies that when there is a p by q form, there will always be a value, right? So if I have a 1 by 2 form, 1 by 2 will also have a value which is 0.5, or if I say 1 by 4, it will have a value which is 0.25, or if I say 1 by 3, it will have a value which is 0.33, and so on. So you can typically say, from when you look at this, you can typically say that rational numbers definition can be given in two ways. One is a number which can be written in the form of p by q, and the other one is a number, rational numbers are numbers which when represented in decimal form is, so when represented in decimal form is either recurring, that is repeating, or terminating. So it's either repeating or terminating, right? So that's a rational number. So any number which is in the p by q form, which is either recurring or terminating, is a rational number. So when I look at recurring numbers, right, so I know that, fair enough, so I know that 1 by 6 is 0.166 and so on, which can also be written as 0.16 bar, and I can, so if I look at now the question as is 0.555 and so on a rational number? So the answer is yes, it's a rational number. Why? Because it's in the recurring form. So if it is in the recurring form, will it have a p by q form? Obviously it will have a p by q form. So what would be the p by q form of a number of this nature? So all I have to do is I have to check how many digits which are unique, right? How many unique digits are repeating itself. So I will check how many unique digits are repeating itself. I realize that there is only one digit which is repeating itself. So I will write that digit followed by number of 9s in the denominator. I repeat, if I want to know what is the fractional value of 0.777 and so on. So there is only one digit repeating, which is 7, and thus I will write 19 in the denominator. If there were two digits repeating, sorry, so let's say 7979 are the digits repeating. If there are two digits repeating, then I would have written the two digits followed by 2 9s. And if there were 3 digits repeating, I would have written the 3 digits followed by 3 nines, and so on and so forth. That would have been the conversion of a decimal form into a P by Q form. This is when I am having everything which is basically a pure recurring number. So I have everything which is a pure recurring number, right? So there is a pure recurring number, there's a pure recurring number, there's a pure recurring number. This is not a pure recurring number. This is a mixed recurring number, because after the decimal point there are certain digits which is not repeating and the rest of the digits is repeating. So when you have a mixed recurring number, the conversion of this into P by Q will be that I will now write all the digits that I see which are distinct. I will write all the digits which I see which are distinct, and from this I'll subtract the digit which is not repeating. This becomes my numerator. I will write all the digits which is distinct, from that subtract the digit which is not repeating, and that becomes my numerator. In my denominator, I will have 9 based on number of digits which are repeating. So that is, there is only one digit repeating, and thus 1 9, and because there is one digit which is fixed, thus comes 1 0. So you will have a 21 upon 90 as a value, which obviously you know that you can simplify and get it up like 7 by 30, right? So you will have a 0.23333, 2333, and so on. So now, if given a question, what kind of questions can be asked here? So what if I say that there is a value d, and d is equal to point a, b, and so on, where a, b are, you know, natural numbers, single digits, 1 to 9 or 0 to 9. Now, and I'm also saying that d into k gives an integer. So if the question is that if d is point AB, and d into k gives an integer, then what can be the value of k? Your answer options are, please listen to the answer options before you type the answer. The answer options are 9 0, 9 9 9, 2 9 7, none of these. So a quick 1 minute time, guys. What do you think your answer is going to be? So out of these 4 options, what do you think your answer is going to be? Don't give me any other answer apart from these 4 options. In these 4 options, what do you think your answer is going to be? Okay, so many of you are saying that the answer is none of these, right? And why do you say the answer is none of these? You're saying answer is none of this because you basically are saying that d is point AB, which means there are 2 digits repeating. So the d value AP by 2 is going to be, you know, P by Q is going to be AB upon 99. This is what you guys are saying. And now you say that d into k has to be an integer. So if d into k has to be an integer, it means that AB divided by 99 should be multiplied with k such that this 99 cancels with this k. I repeat, if d is P by Q, which is A by B, and if you are saying that d into k is an integer, then you are basically saying that AB by 99 into k should become an integer, which means that this 99 should cancel with k. Now 99 can cancel with k, not necessarily only when k is 99. It can be, k can be 99, k can be 198, k can also be 297. So it can be any value of 99, absolutely right. So it is not none of this, but your answer is 297. right? So basically when you're looking at such questions, you are not looking at a value which is direct substitution of your denominator, but you are looking at a value which can eliminate your denominator. Elimination of denominator can happen when you are talking about a multiple of your denominator. Quickly at 5 seconds, 10 seconds, let me know if you have any doubts. Are you clear, guys? Just drop a message if you're clear. Couple of messages will do. Anyone who has a doubt, please raise your doubt. Great. So I'm assuming you're all clear with what we have done till now. Done. Great. So let's proceed further now, right? Now let's look into, let's proceed further. So now let's look into what do we mean by, okay, so some of you want a repetition. So basically it says this, that d into k is giving you an integer. What was d? D was AB upon 99, and you're multiplying that by k to get an integer. This can happen only when 99 cancels k. For example, 1 by 3 can be an integer only when 3 cancels something here. Something here need not be 3. It can be 6, it can be 9, or it can be any multiple of 3. Similarly, 99 can cancel not because k has to be 99. 99 can cancel when k is a multiple of 99. That's when 99 can cancel. So look at your answer option, which is a multiple of 99. Now you realize answer option 3 is 297, which is multiple of 99, and thus that becomes your answer. I hope now you are clear. Now let's go further. The question is, the question that we have here now is going to be, so let's understand quickly, what do we mean by prime numbers? Prime numbers are numbers. So if you ask someone what is a prime number will say prime numbers are numbers which are divisible by 1 and number itself. Basically, we can actually say, or we should actually say, prime numbers are numbers which has exactly 2 positive factors, which is 1 and the number itself, right? 1 and the number itself. So it has exactly 2 positive factors, 1 and the number itself. So that's a prime number. Between 1 to 100, we have 25 prime numbers. Now please understand, prime number begins from 2. 2 is the only prime number which is even, and the rest all of the prime numbers are typically odd. So you have 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. So you will have 25 prime numbers between 1 to 100. I presume that you all know this. If you don't know this, please ensure that you make a list of it so that it comes handy in the near future. Now, and a quick information that you guys want or would like to have is between 101 to 199, there are 21 prime numbers, with 101 being the smallest prime number, smallest 3-digit prime number. Okay, so keep this in handy. Now the next, every prime number can be written in the form of 6k plus 1 or 6k minus 1. Every prime number which is greater than 3, every prime number greater than 3 can be written in the form of 6k plus 1 or 6k minus 1. So you pick any of these prime numbers here greater than 3, you will see that they are all either 1 less or 1 more than a multiple of 3. I mean multiple of 6. So it makes sense. I mean it can always come handy for us when people are talking about prime numbers. Now from here is what we are going to move to finding the last digit or unit digit of a problem. So finding the last digit. Okay, so how about me giving you a question on prime number? Now that we have taught you a prime number, we'll keep this aside, guys, for a minute. Let's look at a question, right? So because we started talking about prime number, so I'm going to give you all 2 minutes exactly to answer this question. I want you guys to maximum answer the question, participate, just tell me the answer, that's all. Okay, I have a set which contains 2 elements. Now some of you would have done this. If you had attended one of my classes, you would have done this, but the others who are attending for the first time, this question probably is for you. P is a set which contains 2 elements, x and y. S is sum of these 2 elements. P is a set which contains 2 elements, x and y. S is sum of the 2 elements, x plus y. The condition is that x, y and s, all the 3 are prime numbers. Condition is that x, y and s, all 3 of them are prime numbers less than 100. Can you tell me how many sets can be made? Your answer options: 1, 2, 8, 7. Last answer option: none of these. I love to give none of these. So the question is again this. You just have to tell me how many P's can you make? Okay, how many sets means how many P's can you make? Your question is pretty straightforward. You have a P which contains 2 elements, x and y. S is sum of these 2 elements, x plus y. The 3 elements that you have in your hand, x, y and s, all 3 of them are prime numbers and they are less than 100. How many P's can be made? So give me the answers. Now many of you are saying 1. Okay, Jubal says 1. Many of you are saying 2. I don't know how you're getting 2, but then you guys are saying 2, so let me take it, right? And anyone else? I'm going to give you exactly. Harshita says none of these. Okay, that's nice. So I'm going to give you exactly 2 minutes for you to work on this. So why don't you work on this? Meanwhile, I have a glass of water. Amrita, you say 6. Are you sure? Yes, Anna, S should be prime. You know, that is the condition. X, Y and S, all 3 of them have to be prime numbers. Amrit, you say 6. Are you absolutely sure? So I got Abhishek Roy who says 7. So we are basically bidding. Come on guys, let's bid more. Let's bid more. Akash. Okay, the question. Okay, Vijay, the questions are pretty straightforward. I'm going to repeat the question to each one of you here. There is a set P which contains two elements x and y. S is x plus y. X, y and z, all three of them are prime numbers. How many sets of P can be made with this condition in my hand? So now you guys are getting the right answer. The right answer is 8. So let's understand how. Okay, so right answer is 8. So let's look into how we are going to get this. How are we going to get this? Now typically you are saying that x plus y is equal to s. So this is what you're saying. And what is the condition? That x, y and s all are prime numbers. So I'm going to go a bit slow here, rather so that I do not have to repeat again. X plus y is equal to s given to me, and the condition given to me is x, y and s are all prime numbers. Now when I look at my previous place where I had given you the list of prime numbers, we had all the numbers to be odd numbers apart from 2. I hope you're clear. When we listed down the prime numbers, we had all the prime numbers listed, to be odd except 2, which means that if I now take x to be odd, y to be odd, and if I add these two odd numbers, my resultant will be even. Now if the resultant has to be even, it has to be bigger than 2, and bigger than 2, there is no other even number which is prime, which implies I cannot add two odd numbers. Now can I add two even numbers? I cannot add two even numbers because I do not have three even numbers which are prime, which implies the only thing left with me is to add an odd number with an even number. Now when I add an odd number with an even number, my resultant is odd. Now I know for the fact that this even number has to be 2. There is nothing else I can have. So I have to have 2 as an even number, and with this I should add an odd number so that my result is now another odd number. So let's look into this. 2 plus 3, 5. 2 plus 5, 7. 2 plus 11, 13. 2 plus 17, 19. 2 plus 29, 31. 2 plus 41, 43. 2 plus 71, 73. 2 plus 59, 61. And that's all. So I have 1, 2, 3, 4, 5, 6, 7 and 8. So I have 8 such pairs. I hope you're all clear with this kind of a question. So please understand that though my question is asking you about a prime, the method that I'm using is not only prime but the basics like even and odd. So it's very important to ensure that we in our mind always keep the basics of our numbers, which means they are even, they are odd. So either I will have even, odd, prime, composite. When I have these 4 things in my hand, my questions in numbers actually becomes much simpler if I try to utilize these 4 things once in a while in a question that needs that kind of a introduction or an information. I hope we are all clear with this. Now let's go further down, right? Let's go further down. Further down is now getting to our last digit, finding the last digit of a number. Now when I give you something like a 324, what is the last digit of 324? We all know obviously it is 4. Now if someone says that 324 into 273, what is the last digit? Typically last digit, when you say 3 4s are 12, and you say that the last digit is going to be 2, right? So the last digit is going to be 2. Now when I say 123 into 727, then you'll say the last digit is 1. Absolutely right. So the last digit becomes so easy because when I'm asking you to find the last digit of a product, it all boils down to the unit digit of individual number, and it is never impacting my entire number. So my number doesn't make any sense, right? So 123, the 1 and 2, which is in the hundreds and the tens place, doesn't make any much of a sense. All I need is a 3 and a 7. So similarly, if someone gives me a 12 into 133 into 244 into 377 into 489, all I know is the 2 here, the 3 here, the 4 here, the 7 here, and the 9 here matters to me, which means 2 3s are 6, 6 4s are 24, so the 4 matters, 4 7s are 28, so the 8 matters, 8 9s are 72, so the 2 matters. So the unit digit of this is going to be 2. So on a very simple note, all I have to say is that irrespective of the size of the number, I have to consider only the last digit of the number. Now let's say someone tells me to find the unit digit of 12 power 3. So it's pretty easy, right? 12 cube is what? 12 into 12 into 12. So you are asking me to multiply 2 into 2 into 2, and I know at any point of time, even in my wildest dreams, that 2 cube is 8, right? So this is something that I'll always remember. We all have done so much math in life, kinds. But what if someone tells me, okay, well, let's try 12 power 9. Given a chance, I will say, okay, 12 power 9 is 2 into 2 into 2 into 2 into 2 into 2, and that's going to go 9 times, right? Not a bad thing to write, because that's not a big number to anyway write it down. So I realize that 2 into 2, that's 4, 4 into 2 is 8, 8 2s are 16, so 16 will contribute this 6, 6 2s are 12, so again I'll have 2 contribution, 2 2s are 4, 4 2s are 8, 8 2s are 16, again a 6 contribution, 6 2s are 12, so a 2 is the unit digit of this entire product. So it becomes much easier for me to understand this. But the day when someone gives me 72 to the power of 71, the unit digit of this will obviously take time if I am trying this method of getting the solution, right? So when someone tells me, okay, what is the unit digit, or if someone asks what is the unit digit of 72 to the power of 71, I will basically look into one part. So 72 power 71, I will now look at the cyclicity of my power of 2, right? So I'm going to look at the cyclicity of power of 2. The cyclicity of power of 2, when you look into it, says 2 power 1 will always give me a unit digit of 2. 2 squared will always give me a unit digit of 4. 2 cubed will always give me a unit digit of 8, and 2 power 4, which is 16, will give me a unit digit of 6. So 2 power 5 is nothing but 2 power 4 into 2 power 1, which means it is nothing but this 6 and this 2. So that's a unit digit again 2, which implies that when I look at 2 power 5, my cycle will now again fall back, and 2 power 5 will be 2, 2 power 6 will now give me 4, 2 power 7 will now give me 8, and 2 power 8 will now give me 6. Similarly, 2 power 9, 2 power 10, 2 power 11 and 2 power 12 will start giving me all these respective unit digits that we are looking at. So all I have to do is look at where is 2 power 71 falling into. Is it falling in this category? Is it falling in this category? This or the last category? This is what I need to check. So checking where this 2 power 71 falls is this. I for a fact know that 2, so when I look at this, guys, when I look at this entire cycle, the only statement I can make which is true always, listen, the only statement that I can make which is always going to be true is that 2 when raised to a power which is a multiple of 4 will always give me a unit digit of 6. This is what it's going to say, right? So when I look at this particular cycle, it tells that 2 when raised to a power of multiple of 4 will always give me 6. This is one statement which will never hold false. It is always going to be true. So when I have a 2 power 71, I will now look at 2 to the power which is 4's multiple plus what balance is left over. So I realize that 2 power 68 is a multiple of 4, and I am now left with 3 more to make it 71. Now 2 power a plus b is always 2 power a into 2 power b. Now 2 power 68, I know because this is a multiple of 4, I know that 2 power 68 will always end in 6 because of this concept. Now what is left over? I am left with 2 cubed, which is 8, and 6 into 8 is 48, so I am left with 8. I hope we are clear. So I am going to write one more on down on the left side. Just give me a minute. I'm going to write down one more, right? So let's say I'm talking about not 2 power 71, or sorry, not 72 power 71, but let's say we are going to talk about something else. So let's say that the question is 72 power 139. Now, so it is nothing but 2 power 139. Now, look at 139. We are always going to use this concept. 2 to the power 4's multiple will always end in 6. This is the base on which your entire work is going to happen. 2 to the power of 4's multiple is always going to end in 6. Now, so now I am looking at 2 power 139. So now 139, I know 4's divisibility rule, right? 4's divisibility rule means the last 2 digits. Now this last 2 digits is 36. So because I am looking at 4's multiple, I will use 4's divisibility rule. So 2 power 139 is nothing but 136 plus 3. So it's 2 power 136 into 2 cube. The 2 power 136, because it falls under the category of 2 to the power of 4's multiple, the unit digit of this is always going to be 6. And I am left with 2 cube, which is 8. So 6 into 8 will always give me 48, which will end in 8. Now, this is one way, guys. There is another way here. You can actually look at, for example, if I look at the previous question of 2 power 71, do you realize that 2 power 72, 72 is a multiple of 4? Yes. So when you say 72 is a multiple of 4, you are looking at a number which is 1 less. So you know 72 is a multiple of 4. So you are looking at a number which is 1 less than a multiple of 4. Now when I look at 1 less than a multiple of 4, do you realize 1 less than a multiple of 4 falls under this category? Right? In my entire cycle, 1 less than a multiple of 4 falls under this category. So 1 less than a multiple of 4 falls under this category, which is 8. So the unit digit of this is going to be 8. Right? I hope you are clear with this. Let me know if you guys have a doubt, or I will clear you again. So let's look into possibilities. Let's look into possibilities. So I can have a question which says 12 power, let me take a simple one, 53, 12 power 54, 12 power 55, 12 power 56. Right? I can have, I've taken 4 examples here. Now what is the unique thing about 4 examples? Apart from that, the denominator is same. Right? So Shreya, Anna, I'm doing this similar example again. All of you guys can look into this. And right, Ananya, this is the same concept that you have been using. So let's look into what we are saying. We know let's look into what the cycle was saying. The cycle was saying that 2 to the power of 1 will end in 2, 2 square ends in 4, 2 cube ends in 8, 2 power 4 ends in 6. This was the cycle saying, right? Now, let's look into this. There is 53, 54, 55, 56. I have used a value which is 1 more than a multiple of 4, because I know 4's multiple, 52 is a multiple of 4, right? 52 is a multiple of 4. So I have used 1 more than a multiple of 4. I have used 2 more than a multiple of 4. I have used 3 more than a multiple of 4. And I have used exactly a multiple of 4. The point is, when the power is a multiple of 4, then the unit digit of that value is going to end in 6. If the number is 3 more than a multiple of 4, so 3 more than a multiple of 4 is 1, 2 and 3. So it will end in 8. 2 more than a multiple of 4. 2 more than a multiple of 4 is 1, 2. So it will end in 4. And 1 more than a multiple of 4. 1 more than a multiple of 4 is a cycle. So this is 1 more than a multiple of 4. This is 2 more than a multiple of 4. This is a multiple 3 more than a multiple of 4. And this is a multiple of 4 itself. So 1 more than a multiple of 4 ends in 2. Right, guys? So this works. So typically, please understand that this is working for the base of 2. So the method that we said, or the earlier thing that I said, that write 2 power 53, then write as 2 power 52 plus 1, then write as 2 power 52 into 2 power 1, 2 power 52 ends in 6, 2 power 1 ends in 2, 6 into 2, 12, 2. So all this step now can be bypassed or ignored, because all I have to do is look at this number, 1 more than a multiple of 4, 1 more than a multiple of 4 ends in 2. Right? Now, now let's look into the other possibility. Do you realize that when you look at this, this is not, okay, sorry, when you look at this, right? So when you look at this, do you realize that 12 power 55 is not only 3 more than a multiple of 4, that is 52 plus 3, but it is also 56 minus 1, which is 1 less than multiple of 4. So if 1 more less than multiple of 4, then it means that I have to go backwards. 1 less than multiple of 4, I will go backwards, and this is going to be 8. So when you have 4k plus 3, you can actually write it as 4k minus 1 also. Similarly, if you have a 4k, let me change the color for you for a minute. So if you have a 4k plus 2, it is same as saying it is 4k minus 2. That is, if a number is 2 more than a multiple of 4, it is also 2 less than a multiple of 4. And if you have a 4k plus 1, you can rewrite it as 4k minus 3. So you can look at going forward or going backwards depending on what are you working with. I hope we are clear. Right guys, so I would like to give you all a minute break. Look at what you have done. See if it has made sense to you with respect to 2 as your denominator or your base value, sorry, not denominator but the base value, if it is making sense for you. If so, then take a minute time and write down the cyclicity of 3, of 7, of 8. So when I say cyclicity, it is what does 3 power 1 end in, what does 3 square end in, what does 3 cube end in, what does 3 power 4 end in, and 3 power 5, 3 power 6, 3 power 7, so on. 7 power 1 ends in 7 square, 7 cubes last digit, 7 power 4's last digit, and 7 power 5, 7 power 6, and so on. Similarly, 8 power 1, 8 square, 8 cube, 8 power 4, 8 power 5, 6, 7, 8, and so on. What are they ending in? Once you are done with this, then look at what is so happening of for 4 and what's happening 4 cyclicity, 9 cyclicity. Write this down in a piece of sheet. I will give you exactly 2 minutes for this. Are you guys done? Great, Surya. Anna, I will explain you the previous question in the later stage probably, right? Let's take off the live, and I hope you guys have done. Yeah, most of you have done. You guys are smart, man. Right. So you basically are saying that, so if I have to look at the possibilities, so this is what is happening. 3 power 1 unit digit is 3, 3 square unit digit is 9, 3 cube unit digit is 7, 3 power 4 unit digit is 1. Now please remember, you do not, I repeat, you do not have to know the values of these, right? So you can just multiply them and get the answer. So 7 power 1 ends in 7, 7 square ends in 9, 7 cube is nothing but 3, and 7 power 4 is nothing but 1. Similarly, 8 power 1 is nothing but 8. 8 square is nothing but 4. 8 cube ends in 2, and 8 power 4 ends in 6. Now, when I look at 4, the easy one I can say is 4 when raised to a power which is odd will end in 4, and 4 when raised to a power which is even will end in 6. I know most of you know this, okay? I will tell you where we are leading it to, and the last question of this entire session will be the question which is worth attempting. I mean, you will then understand the entire cyclicity. Till then, you probably may feel that, okay, I'm doing the same thing again and again, right? Now, 9. Similarly, 9 power odd will end in 9, and 9 power even will end in 1. So this is for 4 and 9. These are for 3, 7, 8. Now the question is, when it comes to digits which end in 1, 5 and 6, numbers that end in 1, 5 and 6 will continue ending in 1, 5 and 6 irrespective of the power. So no matter what power I am talking about, it will continue ending in 1, 5 and 6. So we now are going to look into something else, right? So an extension of whatever we have done. So I'm going to talk to you regarding an example. So let's say I am now giving you a 23 power 23 into a 34 power 34 into a 47 power 47 into a 59 power 59 into a 68 power 68. So let's take this. I will be going very slowly irrespective of how fast you guys are solving it. Now 23 power 23 means what? It means I'm looking at a unit digit of 3 power 23. Similarly, 34 power 34 means I'm looking at a unit digit of 4 power 34, and thus I am looking at unit digit of all of these. I hope we are clear. Sorry, 68. Now I looked at what my cyclicity was talking about. My cyclicity was basically talking about that 3 when raised to a power which is a multiple of 4 will end in 1. But when I look at this, this is 3 to the power 4 multiple minus 1, because it is 23, so it's 24 minus 1. Also, this is 4 and 4 to the power which is even. Guys, I'm writing this down, okay? You don't need to write all these things. 7 to the power of 47. 47 again I know is 48 minus 1. Thus 9, and 9 to the power of an odd number, and 8 is to the power of 68, which is nothing but a multiple of 4. I know for the fact that 3 to the power 4k minus 1, that is one step before a multiple of 4. One step before a multiple of 4, what was the unit digit of 3? 7. Remember 3971? Right. 4 to the power even will be what? 6. Because 4 power odd is 4, 4 power even is 6. 7 to the power of 4's multiple minus 1 is what? It's 3, because 7 was 7931. 9 to the power of odd. 9 to the power of odd ends in 1. 8 power 4's multiple. 8 power 4's multiple is 6. So some of you would have taken this. 3 to the power of 4k plus 3. 4 to the power of even. 7 to the power of 4k plus 3. 9 to the power of odd. And 8 to the power of 4's multiple. Please understand, this place or this place, that is whether you take 4k minus 1 or you take 4k plus 1, it really doesn't matter. They both are the same. Okay? Okay. So that is a mistake. Thanks, Ananya. So 9 power odd. 9 power odd was 9, not 1. 9 power even is 1. 9 power odd is 9. Right? So 8 power 4's multiple ends in 6. 9 power odd is 9. 7 power 4k minus 1 was 7, 9, 3, 1. So 7 power 4k minus 1 is 3, which is same as 7 power 4k plus 3. Right? And thus, what is the value that we are talking about? So we are talking about 7 into 6, 2, 2 into 3, 6, 6 into 9, 4, 4 into 6, 4 again. So 4 becomes the unit digit of this particular value. Right. So this is one kind of a question. Now, I am now going to give you a question, and I want you all to throw up your answer as quickly as possible as soon as you see this particular question. I'm repeating, as soon as you see this question, I want you to start solving and throw me an answer. The question is 173 power 594 into 784 into 496 into 2995 raised to 1445 into 7387 into 1326 into 2998132. Do you want more? Okay, one more. 196 power 196. What is your unit digit? Oh my God, you guys should have got your answer by now. Now you are watching it, now it's coming up. Right guys, the answer is going to be 0. What are you doing? Don't try to do everything else. Look, do you realize that you have an odd number here? Forget the power. Forget the power. Do you realize that you have an even number here? So when an odd number and an even number get multiplied, you'll eventually get an even number. Right. Now when this even number, and do you have a 5 here? So when this even number gets multiplied with 5, do you realize that you eventually end up getting a 0? Which means that once I realize that I have a even number, and then I realize that I have a 5's multiple, I know for the fact that once this is done, I know exactly that an even number and a 5's multiple will always give me a 0. I do not have to do anything else. Right? So it will always give me 0. Now, if I had given this 495 into 23 power 23 into 79 power 79 into 137 power 137, what would have been my unit digit? My unit digit would have been 5. Why? Because there is no even number in my hand. There is all odd number and there is a 5. And 5 when multiplied by an odd number will always give me a 5. Right? So that is it. So all I have to do is couple of things which I have to always keep in my mind. One, whenever someone is asking me to find the unit digit, do I have a 5 in it? is the unit digit being multiplied? Right? Do I have a 5 in it? Is the unit digit being multiplied? What is the base that I am talking about? Is the power becoming a multiple of 4? So when I look at these 4, I should be able to generate my answer immediately. Let's look into something else, right? Let's look somewhere else, something else. Next question that I have for you is this. 1 power 1 factorial plus 2 power 2 factorial plus 3 power 3 factorial plus 4 to the power of 4 factorial plus 5 to the power of 5 factorial all the way till 90 power 90 factorial. Now remember, this is addition, this is a plus. Okay, this is a plus all the way till 90 power 90 factorial. Can you tell me what is the unit digit of this? Take a couple of minutes, guys, no issues. And yes, I will not be able to tell you the answer. We'll solve it together, we'll know the answer. So you guys are saying 0, you're going to 0, 0, 0. Let's see, I don't know. Might be, may not be. Wait and watch. So it's all 0, that's what you guys are saying. Okay, so let's look into what the answer is. 1 power 1 factorial gives me 1. 2 power 2 factorial is 4, unit digit. 3 power 3 factorial is 9. 4 power 4 factorial, because 4 power 4 is an even, 4 power even gives me 6. 5 will always give me 5, 6 will always give me 6, 7 will now give me 1, 8 will now give me 6, 9 will now give me 1, and 10 anyway gives me 0. I'm repeating. 1 power 1 factorial will give me 1, 2 power 2 factorial will give me 4, 3 power 3 factorial will give me 9, because 3 power 3 factorial means 3 power 6, which is 3 square, 9. 4 power 4 factorial will give me 6, because 4 is raised to an even number. 5 power 5 factorial will remain 5. 6 raised to any power remains 6. 7 power 7 factorial will give me 1. 8 power 8 factorial will give me 6. 9 power 9 factorial will give me 1. 10 power 10 factorial will now give me 0. Now this is 1 to 10. Do you think the pattern of 1 to 10 will hold true for 11 to 20? Something in mind? Let's see. 11 power 11 factorial, 12 power 12 factorial, 13 power 13 factorial, 14 power 14 factorial, 15 power 15 factorial, 16 power 16 factorial, 17 power 17 factorial, 18 power 18 factorial, 19 power 19 factorial, 20 power 20 factorial. Do you see the pattern is changing after 11? In fact, from 11 to 20, 21 to 30, 31 to 40, 41 to 50, all of this will have the same pattern. It's not going to change. What is the unit digit here, guys? It's 1, 7, 8, 14, right? So 1 plus 6, 7, 7 plus 1, 8, 8 plus 6, 14, 4, 4 plus 5, 9, 9 plus 6, 15, 5, 5 plus 1, 6, 6 plus 6, 12, 2, 2 plus 1, 3. 20 to 21 to 33, 31 to 43, 41 to 53, 51 to 60, 3, 61 to 70, 3, 71 to 80, 3, 81 to 90, 3. I will come now. I know what's going in your mind. Let's come back to that. Wait. So I have 1, 2, 3, 4, 5, 6, 7, 8. 8 threes with me, which means sum of all this category is 24. Okay. Now sum of all this is 24. Shreyas, just wait. I'll get back to you. Sum of this is 24. Now let's look at here. This is 1 plus 9, 0. 4 plus 6, 0. So this is 0 anyway. So I have 1 plus 6 plus 5 plus 6 plus 1. So how much is that? So 1 plus 6, 7, 7, 14, 4, 4 plus 1, 5, 9. So 9 is a unit digit here, 4 is a unit digit here, 9 plus 4, 3 is my unit digit. Now most of you are confused and none of you have answered it and asking you questions. You are not even asking me doubts. Now what's happening here? Let's understand. I realize that when I'm looking at, so I'm going to change this font, this color now. Look at the values. 1 factorial, oh god, didn't change. 1 factorial, 2 factorial, 3 factorial. 1 factorial is 1, 2 factorial is 1 into 2 basically, 3 factorial is 1 into 2 into 3. But when it comes to this 4 factorial, it is 1 into 2 into 3 into 4. When it comes to this 5 factorial, it is 4 factorial into 5. So when it comes to, let's say, 7 power 7 factorial, 7 factorial is 1 into 2 into 3 into 4 into 5 into 6 into 7. Do you guys realize that after my 3 factorial, every power is a multiple of 4? Because I am multiplying by 4. Every power is a multiple of 4 after my 3 factorial, which means whatever, so let's look into, okay, let's look into 7 power 7 factorial. This is now 7 power 4's multiple, because 7 factorial now is a multiple of 4. So if 7 power 4 factorial will give me 1 as a unit digit, great. Now look at 17 power 17 factorial. Do you realize that this is also a multiple of 4? So this will also give me the same unit digit that 7 power 4 factorial had given. 7 power 7 factorial had given. So will it be the same for 27 power 27 factorial? Will it be same for 37 power 37 factorial? Will it be same for 47 power 47 factorial? Now, this is only 7 that I have taken. In fact, 8 will follow the same, 9 will follow the same, 11 will follow the same, 11, 12, 13, 14, 15, 16, all of these are now going to follow the same. So if 11 will follow what 21 follows, what 31 follows, 41, 51, 61, 71, 81. 12 will follow the same all the way till 82. 13 all the way till 83. 14 all the way till 84, which means whatever the unit digit you get here, it is the same unit digit that you are getting everywhere else. Where you are getting the change is only in the first 3, because the first 3 numbers do not have a power which is a multiple of 4. Okay, 1 will not have an impact, but 2 and 3, yes, right? So that's why if you see The rest, all of them are actually same. The only change has come in this portion. Okay, Mohammed, you are not clear. So I will now repeat this. Okay, I will repeat this for those who are not clear. So let's understand this, guys. 1 power, I'm not going to give, this is nothing called as shortcuts here. I'm trying to build your entire concepts. 1 power 1 factorial, 2 power 2 factorial, 3 power 3 factorial. It went all the way till 90 power 90 factorial. Now, what do you mean by factorial? So when you say 1 factorial, it is 1. When you say 2 factorial, it is 2 into 1. When you say 3 factorial, it is 3 into 2 into 1. When you say 4 factorial, it is 4 into 3 into 2 into 1. When you say 5 factorial, it is 5 into 4 into 3 into 2 into 1. And so on, it keeps going. Once you touch 4 factorial, it will now have, once you touch 4 factorial, it now is a multiple of 4. Which means that beyond 4 factorial, when you start moving, it will remain a multiple of 4 always, no matter what number you go. So, so that's what it is. So when you look at something like, you know, a 7 factorial, it will be a multiple of 4. 17 factorial will also be a multiple of 4. 27 factorial will also be a multiple of 4, and so on and so forth. Right? Ananya, I am sorry, I was not able to understand what you meant. So we are adding here, right? If I had given you 1 power 1 factorial into 2 power 2 factorial into 3 power 3 factorial all the way till 99 power 99 factorial, what would have been your answer? Yeah, your answer would have been 0, because you have an even number, you will come across a 5, that's all, you'll have a 0. Right? So the answer. Right, I have not yet come to my question, which I really love giving you all. But before that, let's do one more, and let's see what kind of a capacity you are holding, right? Are you holding good capacity, or shall we have to stop? Now the next question is this. 2 power, okay, not 2, 12 power 17 into 13 power 14 into 14 power 15 into 15 power 38. 38? Should I give you 38? Okay, let me give you 30. Question is, what is the last non-zero digit? You all have 5 minutes. Ananya, the question is not what is the last digit. The question is what is the last non-zero digit. Why are you guys rushing on to the question? Read the question properly. You all have 3 minutes, 2 minutes, 3 minutes to do this. Aha. Akash, what makes you say 5? Dinesh, you too say 5. Great. Varun saying 6. Ashwin saying 6. Let's see where are you guys leading into. Okay, so let's see what the answer is. So I'm asking you the what is the last non-zero digit. So first, for me to have what is the last non-zero digit, the first thing I have to do is I have to remove all zeros that's possible. Okay, so please understand, listen carefully. For a non-zero digit, I have to remove all possible zeros, right? Now, how do I get a zero? So a zero is generated when you multiply a 2 with a 5, the basic one, right? So basically 0 gets generated when you multiply a 2 with a 5. So first let me see how many 2's do I have. Okay, let me see how many 2's and a 5 do I have. So typically 12 is nothing but 2 square into 3. So 12 power 17 is nothing but 2 square into 3 power 17. 13 power 14 is 13 power 14. Nothing, no 2's there. 14 power 15 is 2 into 7 power 15. And 15 power 38 is 3 into 5 to the power 38. Typically, you're saying that you have 34 2's with you, right? 2 17s are 34. 34 2's with you here. Then you have 14 3's with you. Then you again have 15 2's with you. This one. Along with that, you also have 15 7's. Then you have 38 3's with you, and then you have, so you have 38 3's with you, and then you have 38 5's with you, which implies overall you are saying that you have 49 2's, 52 3's, 15 2's and 38 5's. Sorry, what are you saying? Sorry, this is extra. 15 7's. Are you clear? To make a 0, you require a 10. To make a 10, you require a 2 and a 5. Now, all I will do is split these entire numbers such that I will basically doing a prime factorization. That's what you're doing. The 12 is nothing but 2 square into 3. 4 3's are. So, you're saying 2 square into 3 power 17, 3 power 14, 2 into 7 power 15, and 15 power 38 is 3 into 5 power 38. So you have 12 power 17, which is 2 power 34 into 3. Oh God, what am I doing? I missed out. Sorry guys. Yes, I forgot one. So I'm going to retrace here. So I'm saying 2 power 34 into 3 power 17, that comes from here, into 3 power 14, that comes from here, into 2 power 15, into 7 power 15, into 3 power 38, into 5 power 38. So you are saying I have a total of 2 power 34 plus 15, 49, into 3 power 17 plus 14, that is 31, into 13 plus 14, 31, 31 plus 38, that is 69, into, right, 5 power 38 and into 7 power 15. So you will remove these 5s and you will remove that many 49s, right? You will remove these 5s, that is 38 5s and 38 2s, that will give you that many zeros. So when you remove 38 5s and 38 2s, what are you left with? You are now going to be left with, I'm going to erase this because this was a bit mistake done here. So you are now left with, guys, 38 5s, you have 49 2s, 38 5s and 49 2s. Will it generate 38 zeros with you? So you will have 38 2s and 38 5s generating together 38 zeros. So everything else will now generate, only the non-zero part. Now what is the non-zero part? Non-zero part is being generated because of the leftover 11 2s, the 69 3s and the 15 7s. 2 power 11 ends in what? Ends in 8. 3 power 69. 69 is 4's multiple plus 1. 11 is 4's multiple minus 1. 69 4's multiple plus 1. So will end in 3. 15. 4's multiple minus 1. 4's multiple minus 1 of a base which is 7 has an ending of 3. So what is the total value ending in? 2. So 2 becomes the unit digit of the last non-zero digit of this. I have a smaller space here, so that's why I couldn't, I ended up missing a couple of numbers, but I'm sure that you understood what it is when we finally got it. So a 0 gets converted only when you multiply 10 into 10. Last question of the day. What is the unit digit of 23 part 22 part 21? The last question for the day. Do this. After this, I will come back to the last sum that we did, okay? Because there are some of you who got confused in between. So after this, I'll come back to the last digit we did. Yeah. So guys, what is the unit digit of 23 part 22 part 21? Right, 9999. Oh my god, the answer is 6. The answer is 9. Amrit, Surya, the others. Okay. Basic tells me, Surya says 1, Ashwin says 1. So Surya and Ashwin, can you just quickly tell in the group what makes you think it's 1? Anthony, you too. Great. Can you tell me what makes you say 1? I understood the others, I understood the 9 option. I need to understand 6 that was given by one of you. Who gave me 6? By the way, Amrit, you have to come out with an answer for 6. Okay, and the others who, Anna, you too, probably. I hope you two are not sharing the same window around. You have to come out with an answer. Tell me what 6 is. How did you get 6? And the others who are saying 1, you have to tell me how did you come 1. Rohit is also saying 6. So how do you get 1? How do you get? I know how you get 9. I want to know how did you get 1, and I want to know probably how did you get 6. 6. So all those writing 6. Seriously, do you realize? Aha. Okay. Do you realize that this is an odd number, guys? 23 power something. Guys, 23 power something cannot end in even, no? If you have an odd number and it is raised to a power, it cannot convert itself to an even number, right? So obviously 6 is out. Okay. Now let's understand the concept that people have used to get 9. There are two kinds of people here who can get this 9. So it's okay, don't bother. One who will say 23 power 22 power 21. 23 power 22 power 21 is 3 power 22 power 21. 22 is 2 more than 4's multiple. 2 more than 4's multiple means this is 3 squared 9. So 9 to the power of 21 should give me 9. So this is one kind. Wait. There is another kind who will say 22 to the power of 22 is nothing but 2. 22 power 21 is nothing but 2 power 21. 21 is 20 plus 1. So which means this is 2. So then I have 3 squared. So I get 9. So 9 is the unit digit. Right? So this is the concept used by most of you who got 9. The right answer is 1. Now let's understand how. Surya got it right. Absolutely. Now, let's look at 23 to the power of 22 to the power of 21. What makes a number a multiple of 4? Listen carefully. What makes a number a multiple of 4? A number becomes a multiple of 4 when you multiply 2 times. When you multiply 2 times, the number becomes a multiple of 4. Which means if I have to multiply 14 with 18, this is an even number, which means it is a multiple of 2. This is also an even number, which means it is also a multiple of 2. When I multiply both of them, this product will now be a multiple of 4. On a similar note, if I am multiplying 22 with 26 with let's say 34, this is a multiple of 2, this is a multiple of 2, this is a multiple of 2, this will be a multiple of 8. So for me to know that a multiple of 4 comes only because of a 2 and a 2, no matter what else is there. So if I am saying 2 into 2 into x into y into z into a into b into c, this will always be a multiple of 4 because I already have generated my 4. Do you all understand this? So if you have understood this, coming back to what we were doing, 23 to the power of 22 to the power of 21, when I look at 22 to the power of 21, it means I am saying 22 to the into 22 into 22 into 22 and so on. This is a multiple of 2. This is a multiple of 2. Automatically I have got this to be a multiple of 4. Now whatever I keep multiplying this with, the result will remain a multiple of 4. So when the result remains a multiple of 4, 23 power 22 now straightforward becomes 23 to the power of a multiple of 4, which is 3 to the power of a multiple of 4, and that means the unit digit is 1. Give me a thumbs up if you are okay with it. So all I have to do is, let's say someone gives me this. So someone's given me 47 to the power of 46 to the power of 45 to the power of 44. Can you tell me the unit digit of this, guys? Absolutely bang on, right? There you go. You get the answer. The unit digit is 1. Why the unit digit is 1? Because you have an immediate power which is 46, and now 46 being even, if it is raised to any quantity greater than 1, this value now will automatically be a multiple of 4, and thus I am now going to deal with 47 to the power of multiple of 4, which is 1. Right? Right, guys. So keep practicing more. We have lots to go, you know. So the question was, so couple of things that can come is, what if the value that I am dealing with is 43 to the power of 42, 43 to the power of 43 to the power of 43. Now what would be the unit digit? So it's possible, right? So it's possible that I will not give you this as an even number. I'll give you this as an odd number, right? Then what am I supposed to do? So that's a possibility of this, right? We will cover this when we get into the question that we are trying to deal with, right? So we will cover this in the next session that we are going to do. But then 43 power 43 power 43 power 43, this answer is obviously not 1, okay, because I do not have an even powers. So when I don't have an even power, the power here cannot never be a multiple of 4, so it is not that. So is this going to be out of these 4, what can be the answer? Is it going to be 1? Obviously it's not going to be 1. Is it going to be 3? Is it going to be 9? Is it going to be 7? We will deal with it when we come to our next class, right? But ideally I'll tell the answer, but don't but keep your concept aside. I do not know the kind of concept you have used. You might have used another concept and you would have got this answer. I'm not taking the safe bet. The answer is 7, right? The answer is 7. I don't know what you guys have done, and most of you have got it 7. I'm assuming I'll be very happy if you got it the right way, but if you're not, then let's hold on to it, right? I hope you got 7. Whatever reason, whatever thing that you have done for which you have got 7. Okay, all those who got 7, can you answer this please? What is the unit digit of can you tell me what is the unit digit of this? So you got 3. Right, you get 3. Okay, so we'll come back to this concept in the next class. Most of you have got it right. I hope the concept that you're using is correct. Those who have not got it right, don't worry, we will come back to it. Anna, you are talking about an odd number here. An odd number cannot give you an even digit. The unit digit has to be always odd. Right, guys? So wait for the next session. We will do much more on cyclicity. I hope whatever we have done now and today you have understood, right? And you are raring to go. Do practice a bit more. Figure out that whether you are able to get what you're looking at, and then we can go forward, right? Thanks, guys. Thanks a lot. I hope you guys have my number. So if you are stuck somewhere, if you have any doubts, you can always message me. And as a backup, this is the number that you can connect for any kind of doubts that you have. Thank you, guys. Thanks a lot. Good night.